Hi, so for today, we're going to talk about homogeneous differential equation. This is the part 3 of our video all about homogeneous differential equation. So if you haven't watched my part 1 and part 2, please make sure to watch it. Okay, so let's get started. So if we wish to recall, okay, a homogeneous differential equation should be arranged in this manner wherein we have m in terms of x, y, dx and plus n, which n is the function of in terms of x and y, dy equals 0. So we have two substitution that we are going to use. If m is simpler, if the term m is simpler, we must use the substitution x equals vy, and for the dx, that's v dy plus y dv. If the n in terms of x and y function is simpler, we can use y equals px and dy v dx plus x dv. Okay, so let's get started. So a homogeneous differential equation, again, if they have the same degree, okay, for dx and dy, if each term has the same degree. Okay, so for number 1, let's get started. So we have the quantity of x minus 2y dx plus we have quantity of 2x plus y, we have dy equals 0. Now this is a homogeneous. Why? Because the term x has a degree of 1, 2y has a degree of 1, same for 2x degree of 1 and y a degree of 1. Hence they are all okay. This is a differential equation that is homogeneous. Okay, so now what are we going to use? Is it m or n? If we may wish to recall, this is our m in terms of xy. This is our n in terms of function xy. Okay? So both are simple. Okay? Simple terms. So actually, we can use either m or n. Okay? This is only a suggestion. Okay? So that we would not come up with a uh, complicated integral when we substitute. So in this case, for number 1, it looked like they are simple. Okay, but I would go for n. Okay, let y equals vx. Let's try it. So we have dy v dx plus x dv. Okay. So all of the y here in our differential equation will be replaced by vx, and dy should be replaced by v dx plus x dv. So let's get started. So we have for the quantity x minus 2y, so we have x. Okay, so we have x minus 2 times dy, which is vx. Okay. And then we have dx plus 2x plus, again, we have the substitution of y. We have vx, okay? And then for dy, that is v dx plus x dv equals 0. Okay, so we will do some algebra here. So we have x minus 2vx dx, and here we are going to perform FOIL. Okay, this multiplied by this. So we have first 2x times v dx. That must be 2vx dx. Okay, plus the outer. Okay, 2x times x dv. That's plus 2x squared dv. Plus the inner. We have vx times v dx. That's v squared x dx. Okay? And last, we have vx times x dv. That's vx squared dv. Let me just rewrite the plus sign. Looks like t. Okay, so we have plus. What is that? The last term, we have vx squared dv equals 0. Okay? So, distribute the dx. So, we have x dx minus 2vx dx. This one. And then, we can rewrite this, as we are going to simplify terms of dx and dv. Okay? For us, before we integrate. Okay. So, are there any cancellation? simplification. This is negative 2vx dx. This is positive 2vx dx. So this should cancel. And we are left with x dx plus 2x squared dv plus v squared x dx plus vx squared dv equals 0. Okay? So, what will happen here is that, let me just continue my solution here. Okay? So, all of the terms here contains a least factor of x. So, I can factor out x, okay, of all the terms there. So that I have x, we have dx plus 2x dv plus we have v squared dx, okay, plus vx dx equals 0. And I can divide both sides or multiply both sides by 1 over x so that the x will cancel. So we have dx plus 2x dv plus v squared dx plus vx dx equals 0. Okay, so now we will be grouping dx with dx, all of dx and dv. Okay, so what will happen here is that we have, oops, I'm so sorry. This should be dv. Okay, this should be dv from here. Okay, we have dv. So we have dv here. So we group it dx plus v squared dx plus 2x dv plus vx dv, okay, equals 0. Factor out dx, we have 1 plus v squared dx plus, we can factor out both x and dv, so we have 2 plus v x dv equals 0. Okay, we have factored both x and dv here so that we have this. Now, this is reduced to a certain variable separable wherein we can separate dx in this side and dv, okay, all the terms in containing v on this side. So if I'm going to manipulate this full equation, okay, by dividing it by 1 plus v squared, okay, for this to be cancelled, and of course, over x. So we will be having, uh, let me just erase this. We know that this is the continuation. Okay. So what will happen here, we have dx all over x, okay, plus we have v plus 2 dv all over v squared plus 1 equals 0. So we have separated all the x on the left side, okay, first term with the dx and all the terms of v in dv on the second term. So we have to integrate that, okay. So if upon integrating, we know that this would be ln of x, this one. So this one, I can use the properties of integral. I can separate the numerator. We have v dv all over v squared plus 1 plus we have 2 dv all over v squared plus 1. And we know that this should be equal to c, the integral here, okay, on the right side. So now, what are we going to do? We have to let u, to integrate this, we have to let u equals v squared plus 1. Why? Because we have available v dv on the numerator. So we can use the u substitution. So we have 2v dv. So isolate v dv so that we can perform u substitution. We have du all over 2 equals v dv. Okay. Okay. And this one, we know that we can integrate this. This is v squared. Okay, v squared, not v squared. Okay. So we can integrate this using the arctan. Okay. Wherein this would be our u, the v. Okay. The v itself. Because we can rewrite this as quantity v quantity squared, then plus quantity 1 squared, so that it becomes arctan, integral yielding arctan. So u dv or u is equal to v. Our v or du will be equal to dv. Okay? So the derivative of that is v. So, of course, our value of a is 1 here. Okay, recall your integration yielding inverse trigonometric function. So, we have ln of x, okay, plus we have the integral. It's time for substitution. v dv is du all over 2 all over u. Plus, I can factor out 2 outside of the integral sign so that we have dv all over, that's what I'm saying, v squared plus 1 squared, okay, equals c. So, when we have integral of the arctan, we know that the integral of du all over u squared plus a squared, where a is any constant, that is 1 over a, arctan of u all over a. Okay? So we have ln of x. We can factor out 1/2. That would be plus 1/2. So this would be du over u, integral of du over u, that is ln of u, plus 2. Okay? This is very straightforward. Here is our formula. 1 over a, which is 1 over 1. You have arctan of u, okay, which is equal to v over a, which is 1, okay, equals c. So we can simplify now this 1/2 ln of u. The u here is the v squared plus 1. So if we back sub it, so because here is our u. Okay? So plus 2 arctan of v equals c. So I could simplify this term so that I can eliminate 1/2, multiply both sides by 2. So we have 2 ln of x plus ln of v squared plus 1 plus 4 arctan of v equals c. 2c or c. That is still equal to c. That is still equal to constant. Okay? So by properties of natural logarithm, these two can be what? Rewritten. These 2 ln x can be rewritten by ln x squared. Whatever the constant, okay, we can raise it up as an exponent inside the ln. So we have ln of x squared plus ln of v squared plus 1 plus 4 arctan of v equals c. Okay? And by properties of natural logarithm, when we have the same base, ln, and then added by an ln, okay, we can simplify it by ln, okay? We have x squared, we simply multiply it, v squared plus 1. That's like having an ln of a, for example, plus ln of b, okay? That is equivalent, ln of a plus ln of b is equivalent to ln of AB. Okay, that's what we did here. Plus 4 arctan of V equals C. Are we done? Not yet. We have to back sub the value of V. What is the value of V? The value of V here will be coming here. So if we get V in terms of this equation, that is y over x. But V is equal to y over x. So if we substitute that, that will be ln of x squared. V squared will become y squared all over x squared plus 1 plus 4 arctan of y all over x equals c. So simplify this. We have ln of x squared y squared all over y squared cancel plus x squared plus 4 arctan of y all over x equals c. And then finally, our answer would be ln of x, I mean, sorry, this should be x squared y squared all over x squared. So x squared will cancel. We are left with y squared. So that must be y squared. Okay? Plus x squared plus 4 arctan of y all over x equals c. Okay? And that is our final answer. ln of x squared plus y squared plus 4 arctan of y all over x equals c. That is our answer for our problem number 1. So for the problem number 2, let's try x cosecant of y over x minus y dx plus x dy equals 0. So this would be our m in terms of xy function, and this would be our xn in terms of xy. So even though it has no term as y, still we have to consider this as our n. Okay? So what is simpler? N is simpler. Okay? So we have to use the substitution of, again, that is still y equals vx. So we have dy equals v dx plus x dv. Okay? So let's get started. So we have x cosecant of y all over x. Okay? Vx all over x. As you can see, the x would cancel. Minus, okay, we have y, which is vx, and then we have dx plus x multiplied by the dy, which is v dx plus x dv equals 0. Okay? So we have x cosecant of v minus vx. This is multiplied in dx. And if I'm going to distribute this, this would be vx dx plus x squared dv equals 0. So now I'm going to distribute dx. So we have x cosecant of v dx minus vx dx plus vx dx plus x squared dv equals 0. And we can see, okay, that minus vx plus vx dx would cancel. Okay? So we have x cosecant of v dx plus x squared dv equals 0. So as you can see also that we can multiply this by 1 over x because it has a common x here and x here, so that our equation would be simplified. So I have cosecant v dx plus x squared over x would be x dv equals 0. Now we have reduced, okay, the equation, okay, into variable separable. We have dx here, we have dv, so we can have it dx all over by this x plus we have dv all over cosecant of v equals 0. And now it is time to integrate this function, okay, for us to get the results. Eliminate dx and dv. So we have ln of x plus this 1 over cosecant v is equal to sine of v. Okay, that's the reciprocal identity. Okay, and we know that this is c. Reciprocal identity. So the integral of sine v would be negative cosine of v, okay, equals c. Okay? So here's the thing. We have an ln x here. Okay? So we have to find another ln for this to be simplified. Okay? So, and we will be using the c. Okay? So, if I'm going to transpose negative cosine b, that will become ln x. Transposing this on the right side or left side, it becomes negative c. Now, this is for the purpose of the sign, okay, that we are going to simplify this ln. Okay? So in my previous video, I said it doesn't matter if you transpose plus c or minus c. That is because we don't have any ln, and it can be easily simplified, okay, without the ln. So in this case, we have ln x minus c equals cosine of v. Okay? So how do we simplify this ln together with a constant? So I would let c equal to this, ln of x. So we have ln of x. Okay? Now, No, ln of c, I mean. Okay, ln of constant, because that is the constant. So we have ln of x minus ln of c equals cosine b. Okay, doesn't matter if I have ln here, because this c equals ln of c is still a constant. So for simplification only of ln. So we have now again to simplify this by properties of ln of x all over c. Okay? So if we have ln of a minus ln of b, okay? This should be ln. I'm tired writing. ln of b. That would be ln of a all over b, which is the same as thing that we did here. So equals cosine of b. Okay? So that we have ln of x all over c equals, we have to back substitute v is equal to, from this formula, okay, v is equal to y over x again. So that we have cosine of y all over x. And this is our final answer. Okay, for now, we will be stopping here. Two problems only. I will be uploading another part 4. Okay, because the solution is lengthy. So I hope you learned something for today's video. Thank you so much for listening. Again, this is Engineer Abat. And if you like this video, please don't forget to subscribe to my channel and hit thumbs up. And please don't forget to share it with your friends, engineering friends who are struggling or currently taking differential equations. So thank you so much for listening. God bless you.